Hello everyone, today we'll be discussing in this video practical applications and how this applies to interrupts and things consisting of that nature, like interrupt handling and so on. In previous videos we talked about this, and today we're going to be looking at some common examples we might see, like in our devices, to things on our operating systems. So let's begin. Alright, so our next topic is what is practical application in interrupts? So interrupts are used in real-world systems to ensure timely responses to events and efficient resource management. So the purpose and their uses could be it ensures a fast response and allows systems to react immediately to important events, and it can optimize CPU usage, which means it prevents wasted processing power by executing tasks only when needed. And so examples of this can be keyboard and mouse inputs. So interrupts detect key presses and the mouse movements. And so for real-time systems, we have medical devices and systems that rely on interrupts for precise timing. And another example is networking. So routers and servers use interrupts to handle incoming data packets efficiently. So our next point is, how do practical applications work in operating systems? So operating systems use interrupts to manage hardware and software efficiently and ensuring a smooth multitasking responsiveness. So some points to consider are the process scheduling, and this means that the operating system uses interrupts to switch between tasks and ensures a fair CPU usage. Next we have device communication. So hardware devices like keyboards and printers signal the operating systems via interrupts for efficient data handling. And next we have error handling, which means that the operating system detects and responds to critical errors like hardware failures using these interrupts. So now our next point is, how is this implemented in device system components? Part 1. So interrupts are integrated into device components to enable efficient communication between the hardware and the operating system. So some points to consider are the interrupt controllers. They manage multiple interrupt signals from different devices and prioritize them for the CPU. Next we have devices. So keyboards, mice, and storage devices use interrupts to notify the system when user input or data transferred is required. And next we have is timers and sensors, and this can mean real-time systems use hardware timers and sensors that trigger interrupts for precise task execution. So our next point is, how is this implemented in device systems, components, and hardware versus software? Now this will be a part 2 of the continuation from the last one. So interrupts can be handled at both the hardware and software levels to manage system events efficiently. So with hardware interrupts, they are triggered by physical components such as the keyboard or the drivers, and they signal to the CPU for immediate attention. With software interrupts, we get generated by programs or the operating system to request system services. So for example, system calls, exceptions, handling, and the key differences between these is that hardware interrupts are asynchronous while software interrupts are synchronous. So that means it's executed within the CPU. Our next topic is examples of interrupt handling techniques in different operating systems. So operating systems manage interrupts to ensure that the system responds quickly to important tasks, like pressing a key on the keyboard or receiving network data. And here we have different examples of how different systems handle it. So for Linux, we have an IRQ, which is an interrupt request. And the interrupt request is a number assigned to each hardware device, like a keyboard or mouse, to interrupt the CPU when a device needs attention. So if you press a key, for example, the keyboard sends an interrupt signal to the CPU, telling it to process the keystroke. And so for Windows, we have an IRQL. And this means it's a priority level assigned to the interrupts. The higher the level, the more important the interrupt is, and the CPU will handle it first. So for example, if a system error occurs like a hardware failure, it has a higher level than a regular keyboard interrupt, meaning the system will address it immediately. And so next we have the Mac operating system, and we have preemptive multitasking, and this means that the operating system can stop one task to handle a more urgent one, like processing an interrupt from your mouse. So for an example, when you click your mouse, the Mac may temporarily pause another task, like a video, to respond to the click. So in this way, it ensures that each system that the most critical tasks are handled first and that the CPU is always ready to respond to these new events. Alright, and with that we have come to the end. Thank you for watching. Please feel free to like, comment, share, subscribe. Hopefully this video gave at least some tips towards this subject. So thanks for watching and have a good one.